Hello and greetings to everyone. We will continue from where we ended last time with the following exercise for application on changing from one base to another. The question goes, change the following. For A, we have this binary number 100101 in base 2. We have to change it to base 4. Remember, for us to change from one base to another, first thing, we need to change the number to base 10. After changing the number to base 10, then we change the result in base 10 now to the given base by making use of repeated division. Take solution. For E, we have to change 100101 in base 2 to a new base of 4. First thing, we need to convert 100101 in base 2 to base 10. For us to convert this number to base 10, first thing, we need to expand this number in powers of the base 2. So this will give us 1 times 2 raised to the power 1, 2, 3, 4, 5 plus the other digits are 0, so we ignore them, plus 1 times 2 raised to the power 1, 2 plus the last digit 1 times 2 raised to the power 0. This will simply give us 1 times 2 times 2 times 2 times 2 times 2 plus 1 times 2 times 2. 2 to the power 3 is simply 2 times 2 plus 1 times 1. 2 raised to the power 0 is 1. This will give us 2, 4. 4 times 2 gives us 8 times 2, 16 times 2, 32 plus 1 times 2 is 2 times 2, 4 plus 1 times 1, 1. This will give us 32 plus 4, which gives us 36. 36 plus 1 gives us 37. Next step, now we need to convert the number 37 to base 4. That's what we have to do. We need to convert 37 to base 4. So we are going to make use of the method of repeated division. For the first column, we have the new base 4. Next, we have 37. Then the third column, we have the remainders. We divide 37 divided by 4. The whole number part will simply be 9. For us to get the remainder, we know 4 times 9 gives us 36. 37 minus 36 gives us 1. Next, we bring down 4. 9 divided by 4 gives us 2, remainder 1. We bring down 4. 2 is less than 4, so if we divide 2 by 4, the whole number part will be 0 and the remainder will be 2. We copy from bottom to top. The number 37, we start from bottom to top, 211. Then we must write down the base, which is 4. Then we conclude, therefore, the number 100101 in base 2 is simply the same as 211 in base 4. We underline the answer. Next, now we go to question B. For B, we have the number 1, 1, 1, 1, 1, 0. We have to change it to base 5. This first thing, we need to convert 1, 1, 1, 1, 1, 0 in base 2 to base 10. So for us to perform this conversion, we need to expand this number in powers of the base, which is 2. This will simply be equal to 1 times 2 raised to the power 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, plus 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 1 times 2 raised to the power 1. The last digit is 0, so we are going to ignore it. 1, 2, 3, 4, 5. This will simply give us 1 times 2 times 2 times 2 times 2 times 2 plus 1 times 2 times 2 times 2 times 2 plus 1 times 2 times 2 times 2 plus 1 times 2 times 2 plus 1 times 2. Next thing we have to simplify. 1 times 2 gives us 2 times 2 4 times 2 8 times 2 16 times 2 32 plus 2 4 8 16 plus 2 4 8 plus 2 4 plus 2. Next, 32 plus 16 gives us 48 plus 8 gives us 56 plus 4 gives us 60 plus 2 gives us 62. Next step now we have to convert 62 to base 5, the new base. Convert 62 to base 5. So we are going to convert this 62 to base 5 by making use of repeated division. Let's do the convention. For the first column we have 5, which is the new base. Second column we have 62. And for the third column we have the remainder. 62 divided by 5 gives us the whole number part of 12. Remainder 2. You know 12 times 5 gives us 60. 62 minus 60 gives us 2. We bring down 5. 12 divided by 5 gives us 2. Remainder 2. We bring down 5. 2 is less than 5. So if we divide 2 by 5, we are going to obtain a whole number part of 0 and a remainder of 2 that we copy from bottom to top. The number 62 in base 5 is the same as 2, 2, 2 base 5. Then we conclude, therefore, the number 1, 1, 1, 1, 1, 0 in base 2 is the same as 2, 2, 2 in base 5. We underline the result. Next, now we go to question C, which says we have been given a number 1, 0, 0, 2 in base 3. We have to change this number to base 2. First step, we have to convert the number 1, 0, 0, 2 in base 3 to base 10. For us to perform this convention, we need to expand the number 1, 0, 0, 2 in base 3. We need to expand this number in powers of the base 3. This will give us 1 times 3 raised to the power 1, 2, 3 plus the other digits are 0, so we are going to ignore them, plus 2 times 3 raised to the power 0. Because after 2 there is no other digit. This will give us 1 times 3 times 3 times 3 plus 2 times 3 raised to the power 0 is simply 1. This will give us 1 times 3, which is 3. 3 times 3 gives us 9. 9 times 3 gives us 27 plus 2 times 1 gives 2. 27 plus 2 gives us 29. Next step, we have to convert the number 29 to base 2. We are going to make use of repeated division. For the first column, we have the new base, which is 2. The second, we have 29. And for the next, we have the remainder. 29 divided by 2 gives us a whole number part of 14 and a remainder of 1. We know 14 times 2 gives us 28. 29 minus 28 gives us 1. We bring down 2. 14 divided by 2 gives us 7. That's a whole number part and a remainder of 0. We bring down 2. 7 divided by 2 gives us 3. Remainder 1. We bring down 2. 3 divided by 2 gives us 1. Remainder 1. We bring down 2. 1 is less than 2. If we divide 1 by 2, we are going to obtain a whole number part of 0 and a remainder of 1. We copy from bottom to top. The number 29 is simply equal to 1, 1, 1, 0, 1 in base 2. We conclude, therefore, the number 1002 in base 3 is the same as 11101 in base 2. We underline the answer. Now we go to question D. For D, we have the number 643 in base 7. We have to change this number to base 6. First thing, we need to convert the number 643 in base 7 to base 10. And we are going to make use of, we are going to expand this number in powers of the base 7. This will give us 643 in base 7 to be equal to 6 times 7 raised to the power 2 plus 4 times 7 raised to the power 1 plus 3 times 7 raised to the power 0. This will simply give us, this will simply be equal to 6 times 7 times 7 plus 4 times 7 plus 3 times 1. This will give us 6 times 7 is simply equal to 42. 42 times 7 will give us 294 plus, next we go to 4 times 7 gives us 28 plus 3 times 1, which is 3. This will give us a 28. This will give us 294 plus 28, which gives us 322. And plus 3, it gives us 325. Next, now we have to convert the number 325 to base 6. We are going to make use of repeated division. So for the first column, we have the base, which is 6. The second one, we have the number 325. And for the last one, we have the remainders. We are going to divide 325 by 6. We divide 325 by 6 gives us 54, the whole number part. For us to get the remainder, we are going to take 54 times 6. 54 times 6 gives us 324. 325 minus 324 gives us 1. Next, we bring down 6. Divide 54 by 6. It gives us 9. The whole number part is 9 and the remainder is 0. Bring down 6. 9 divided by 6 gives us 1 remainder, 3. Bring down 6. 1 is less than 6. So if you divide 1 by 6, the whole number part will be 0 and the remainder will be 1. Then we copy from bottom to top. The number 325 is simply equal to 1301 in base 6. So we conclude, therefore, the number 6433 in base 7 is simply the same as 1 3 0 1 in base 6. Underline the result. Then we go now to the last question. Here we have 1 5 8 in base 9. Let's convert this number to base 3. First thing, we need to convert 1 5 8 in base 9 to a new base, which is base 10. This will give us 1 5 8 in base 9 to be equal to 1 times 9 raised to the power 1 2 plus 5 times 9 raised to the power 1 plus 8 times 9 raised to the power 0. This will give us 1 times 9 plus 5 times 9 plus 8 times 1. This will be equal to 9 times 1 times 9 gives 9 times 9 gives 81 plus 5 times 9 gives us 45 plus 8 times 1 gives us 8. Next we have 81 plus 45 gives us 126 plus 8 gives us 134. Next we have to convert the number 134 to base 3. Convert 134 to base 3. For us to convert the number 134 to base 3, we are going to make use of repeated division. For the first column, we have 3, the new base. The second column, we have the number 134. And for the third column, we have the remainders. 134 divided by 3 gives us a whole number part of 44. If we take 44 times 3, we are going to obtain 132. 134 minus 132 gives us 2, a remainder of 2. We bring down 3. 44 divided by 3 gives us a whole number part of 14 and a remainder of 2. We know 14 times 3 gives us 42. 44 minus 42 gives us 2. We bring down 3. 14 divided by 3 gives us a whole number part of 4. You know, 4 times 3 gives us 12. 12 minus 14 minus 12 gives us 2, remainder of 2. We bring down 3. 4 divided by 3 gives us a whole number part of 1 and a remainder of 1. We bring down 3. 1 divided by 3, we know 1 is less than 3. The whole number part will simply be 0 and the remainder will be 1. Then we copy from bottom to top. The number 134 in base 3 is simply equal to 1 1 2 2 2 in base 3. We must write down the base. Therefore, the number 158 in base 9 is the same as 1 1 2 2 2 in base 3. Underline the result. And we are done with the correction of the exercise for application. Now we move to the next thing, which is arithmetic in any given base. When we talk of any number base, that means base 2, base 3, base 4. In this case, base 10 is excluded. Arithmetic in any base, let's write this down. Arithmetic in any base, arithmetic in any other base, is similar to arithmetic in base 10. We shall carry out addition, subtraction, multiplication, and division of numbers in any given base. The first one, we have addition. We are going to see how to add any two given numbers in a particular base. Unlike in base 10, where we reserve tens, in any other base, we reserve the base. For example, in base 2, we reserve 2's, and in base 5, this is another example. Let's take example rules. Evaluate the following. This is an O. Evaluate the following. A, we have 1 0 1 1 0 1 in base 2 plus 1 1 0 1 0 in base 2. For B, we have 2 3 4 in base 5 plus 2 1 3 in base 5. Take now solution. Take A, we have 1 0 1 1 0 1 base 2 plus 1 1 0 1 0 base 2. For us to add these two binary numbers, first thing we need to start by writing the first number 1 0 1 1 0 1 in base 2, and for the second number we are going to write the second number directly below the first number in such way that the bases will be vertically aligned. It will be on a straight line. So here we write the base 2, then we have the lowest place value, which is a 0. We are going to place the 0 under this one. The next one, we have the digit 1. We are going to place it under 0. Next, we have this 0. We are going to place it under the digit 1. Next, we are going to place 1 under 1. And lastly, we are going to place 1 under this 0. Then we draw our horizontal line. Then we put the addition sign in front. Then we add the digits under each vertical alignment. All the digits under any vertical alignment, we have to add them, starting from the right hand side to the left. First thing, we are going to write down the base 2. 1 plus 0 gives us 1. We write 1. 0 plus 1 gives us 1. We write 1. 1 plus 0 gives 1. We write 1. 1 plus 1 gives us 2. Since we are working in base 2, we cannot write the digit 2 here. It becomes wrong. So what we are simply going to do is we are going to divide 2 by 2, gives us 1 as the whole number part, remainder 0. The remainder is 0. So we are going to write 0 here. Then we carry 1, the whole number part. 0 plus 1 gives us 1. Plus this 1 we carry gives us 2. 2 divided by 2 gives us 1 remainder 0. We are going to write down 0. We carry 1. Here now we have 1 plus nothing remains 1. Plus the 1 we carry gives us 2. We know 2 in base 2 gives us the whole number part of 1 and the remainder 0. We are going to write the remainder first, which is 0. Then we write down the whole number part 1. As a result, we underline it. For the next, now we go to B. B, we have 2 3 4 5 plus 2 1 3 in base 5. We have to add. We need to arrange the digits of the two numbers. We have 2 3 4 in base 5. For the second number, we are going to write the base here. The bases should be vertically aligned. Under 4 we have 3. Under 3 we have 1. Under 2 we have 2. Then we put the addition sign. Then we draw our horizontal line. Then we add the digits, starting from the right hand side to the left. First we are going to put the base, which is 5. 4 plus 3 gives us 7. 7. The digit 7 is not used in base 5 because 7 is more than 5. So if we divide 7 by 5, it gives us a whole number part of 1 and a remainder of 2. We are going to write down the remainder 2, carry the whole number part 1. 3 plus 1 gives us 4, plus the 1 we carry gives us 5. In base 5, we cannot make use of the digit 5. So 5 divided by 5 gives us the whole number part of 1 and the remainder of 0. We write down 0, we carry 1. 2 plus 2 gives us 4, plus the 1 we carried gives us 5. 5 in base 5 is simply 1 remainder 0. So we are going to write the remainder here 0, then the whole number, and we are done. This is a result. We underline the answer. Next, now we go to 2i, which is subtraction. 2i, we have subtraction. Unlike preserving tens or taking tens from one digit to another as in base 10. That means when we are carrying out subtraction in base 10, as in base 10, in other bases, we reserve or take the base from one digit to another, Now let's take an example on this. Take 3i multiplication. When multiplying two numbers, let's write this down. When multiplying two numbers in a given base, we reserve the base as we do reserve tens, when multiplying two numbers in base 10. When multiplying two numbers in base 10. Next, now let's take an example on this. Example goes: evaluate the following. For A, we have 3, 2, 1, 1 in base 4 minus 2, 3, 2 in base 4. For B, we have 7, 6, 5, 4 in base 8 minus 3, 7, 7, 1 in base 8. We have these two questions. We take solution. A, we have 3, 2, 1, 1 in base 4 minus 2, 3, 2 in base 4. First thing, we are going to arrange the two numbers. We are going to start from the first number. We write down the first number: 3, 2, 1, 1 is of a base 4. Next, we are going to arrange the second number such that it lies below the first number, and the bases should be vertically aligned. It should be on a straight line. So the base 4 will be here. Then the digit 2 will be under 1 since they have the lowest place values. 3 will be under 1 again. It's 3. Then 2 will be under 2. Then we put the minus sign. Let's subtract the digits. Starting from the right hand side to the left. Here we have 1 which is less than 2. Since 1 is less than 2, we are going to move to the digit which is at the next higher place value. And here we have 1. And we know this 1 here represents a 4. So we are going to take this 1 down to this lower place value, which becomes a 4. 4 plus 1 gives us 5. 5 minus 2 gives us 3. Bring the base. Here now we are left with 0. 0 is less than 3. We are going to move to the next higher place value. We are going to take a 1 here, which represents 4. Take 1 to this 0. We know the one we are taking represents 4. 4 plus 0 gives us 4. 4 minus 3 gives us 1. Here now we are left with 1 which is less than 2. We are going to move to the next higher place value. We take a 1 which represents 4. We are going to add the 4 to 1. It gives us 5. 5 minus 2 gives us 3. Here now we are left with 2. 2 minus nothing remains 2. We're going to obtain a result of 2, 3, 1, 3 in base 4. Next, now we go to B. For B, we have 7, 6, 5, 4 in base 8 minus 3, 7, 7, 1 in base 8. First thing, we need to arrange the digits of the two numbers such that the bases are vertically aligned. 8 has to be here, the base 1 here, 7, 7, 3. Then draw horizontal line. Then we put the subtraction sign. 4 minus 1 gives us 3. Write 3, then we bring the base. Next we have 5, which is less than 7. So we are going to move to the digit which is at the next higher place value. We take a 1 from there, which represents 8. So this will give us 5 plus 8. And 5 plus 8 is simply equal to 13. 13 minus 7 gives us 6. Here now we are left with 5. 5 is less than 7. So we are going to move to 7, which is at the higher place value. The higher place value, we are going to take 1 from it, which represents 8. This will give us 8 plus 5, which is equal to 13. 13 minus 7 gives us 6. Now here we are left with 6. 6 minus 3 gives us 3. We are going to obtain 3, 6, 6, 3 in base 8 as a result. And we are done with subtraction. We go to the next one, which is multiplication. Take 3i, multiplication. Multiplication, when multiplying two numbers, let's write this down. When multiplying two numbers in a given base, when multiplying two numbers in a given base, we reserve the base as we do reserve tens, when multiplying two numbers in is 10. When multiplying two numbers in base 10. Next, now let's take an example on this. Evaluate the following. For E, we have 2, 3, 4 in base 5 times 2, 4 in base 5. B, we have 6, 4, 2, 4 in base 7 times 1, 5 in base 7. Next, we take solution. For the first one, E, we have 2, 3, 4 in base 5 times 2, 4 in base 5. For us to multiply these two numbers, first thing, we need to start by arranging them. We write 2, 3, 4 for the first number, it is in base 5. Then the second number, we are going to write the base in such a way that they are vertically aligned on a straight line. 4 will be here, 2 will be here. Then we put an X for multiplication, the multiplication sign. Then we draw our horizontal line. We have to start from 2, which has a higher place value than 4. So we are going to fix a 0 here. Then we bring down the base 5. 2 times 4 gives us 8. 8 is more than 5. The number 8 in base 5 simply gives us 1 remainder, 3. We are going to write down the 3 here, the remainder, then we carry 1. 2 times 3 gives us 6 plus 1, 7. 7 in base 5 gives us 1 remainder, 2. We are going to write the remainder here, 2, then we carry 1. 2 times 2 gives us 4 plus the 1 we carry gives us 5. 5 in base 5 gives us 1 remainder, 0. 0, 1. Next, now we go to 4, which is at a lower place value. 4 times 4 gives us 16. 16 in base 5 gives us 3, remainder 1. We are going to write down the remainder here, 1. We bring down the base, we carry 3. 4 times 3 gives us 12, plus the 3 we carry 15. 15 in base 5 gives us 3, remainder 0. We are going to write 0 here, then we carry 3. Next, 4 times 2 gives us 8, plus the 3 we carry gives us 11. 11 divided by 5 gives us 2, remainder 1. We are going to write the remainder here, 1. Then we write 2 here, the whole number part at the higher place value. Then next thing we have to add, starting from the right hand side to the left. 0 plus 1 remains 1. We bring the base. 3 plus 0, 3. 2 plus 1, 3. 0 plus 2, 2. 1 plus nothing remains 1. We are going to obtain a result of 1, 2, 3, 3, 1 in base 5. Let's underline the answer. And this is our result. For B, we have to multiply the number 6, 4, 2, 4 in base 7 by 1, 5 in base 7. First thing, we need to write down the first number 6, 4, 2, 4 in base 7. Then the second number 7 will be here, 5 will be under 4, and lastly 1 will be under 2. Then we draw this horizontal line, then we put the multiplication sign. 1 has a higher place value than 5. Start with 1, we are going to fix a 0 here at the lowest place value. Then we bring down the base 7. 1 times 4 gives us 4. 1 times 2, 2. We are going to write it on the higher place value. 1 times 4 gives us 4. We write 4 here. Then 1 times 6 gives us 6. We write 6 here. Next, now 5 times 4 gives us 20. 20 is already more than 7. We know 20 in base 7 will simply give us 2 remainder 6. We are going to write down the remainder 6, bring down the base, then we carry the whole number part 2. 5 times 2 gives us 10, plus the 2 we carried gives us 12. 12 in base 7 will simply give us 1 remainder 5. We are going to write down 5 here, we carry 1. Next, 5 times 4 gives us 20, plus the 1 we carry gives us 21. 21 in base 7 gives us 3 remainder 0. The remainder is 0. We are going to write 0, then we carry 3. Next, now we go to 5 times 6. 5 times 6 gives us 30. 30 plus the 3 we carried, plus this 3 gives us 33. Next, now 33 in base 7 give us 4 remainder 5. We are going to write the 5 here, which is the remainder, and the whole number part we take it to the next higher place value. Write 4 here. Then we add. We are going to draw another horizontal line. 0 plus 6 gives us 6. We bring down the base 7. 4 plus 5 gives us 9. 9 is already more than 7. We know 9 in base 7 gives us 1 remainder 2. We write 2, we carry 1. 2 plus 0 remains 2 plus 1, we carry 3. 4 plus 5 gives us 9. 9 in base 7 gives us 1 remainder 2. We write down 2, we carry 1. 6 plus 4 gives us 10. 10 plus the 1 we carry gives us 11. 11 in base 7 gives us 1 remainder 4. We are going to write down the remainder here, which is 4. Then the whole number part 1, we take it to the next higher place value. We underline our answer. This is the answer. Now to IV, we have division. To divide any two given numbers. Divide any two given numbers in a particular base. Change the two numbers. Change the two numbers. Change the two numbers to base 10. Base 10. Carry out the division. Carry out the division of the two numbers which have been changed to base 10 to get the result, the quotient, get the result, and then convert the result, that is the quotient, then convert the result back to the given base, back to the given base. Example, it goes, evaluate the following. evaluate the following. For A, we have 1, 0, 0, 1, 0 in base 2 divided by 1, 0 in base 2. B, we have 2, 3, 1, 0 in base 5 divided by 2, 0 in base 5. Take solution. We take A. For A, we have 1, 0, 0, 1, 0 in base 2 divided by 1, 0 in base 2. First thing, we need to convert these two numbers to base 10. If you take the first one, 1, 0, 1, 1, 0, 0, 1, 0, base 2 will simply be equal to 1 times 2 raised to the power 1, 2, 3, 4, plus the other digits are 0, so we are going to ignore them, plus 1 times 2 raised to the power 1. This will simply give us 1 times 2 times 2 times 2 times 2 plus 1 times 2. This will give us 1 times 2 gives 2 times 2 4 times 2 8 times 2 16 plus 1 times 2 gives us 2. 16 plus 2 gives us 18. Next, we need now to convert the next number 1 0 in base 2. Number 1 0 in base 2 will simply be equal to 1 times 2 raised to the power 1. This will simply be equal to 1 times 2, which is 2. Next, now we have 18 divided by 2. 18 divided by 2 gives us 9. 9 is the result. Next, now we have to convert 9 to base 2 because we have been given the two numbers in base 2. Convert 9 to base 2. We are going to make use of repeated division. 2, 9, and the remainders. 9 divided by 2 gives us 4, remainder 1. We bring down 2. 4 divided by 2 gives us 2, remainder 0. We bring down 2. 2 divided by 2 gives us 1, remainder 0. We bring down 2. 1 is less than 2. So if we divide 1 by 2, the whole number part will simply be 0, and the remainder will be 1. We copy from bottom to top. 9 is simply equal to 1, 0, 0, 1 in base 2. We conclude therefore 1, 0, 0, 1, 0 in base 2 divided by 1, 0 in base 2 will simply be equal to 1, 0, 0, 1 base 2. Underline the answer. We are done with the division. We go now to question B. For B, we have the number 230, 2310. This is 1, 2310 in base 5 divided by 20 in base 5. First thing, we need to convert these two numbers to base 10. If you take 2310 in base 5, it will simply be equal to converting it to base 10. This will give us 2 times 5 raised to the power 1, 2, 3 plus 3 times 5 raised to the power 1, 2 plus 1 times 5 raised to the power 1. This will give us 2 times 5 times 5 times 5 plus 3 times 5 times 5 plus 1 times 5. This will simply be equal to, we know 5 times 5 times 5 gives us 125. 125 times 2 will simply give us 250 plus 3 times 5 gives us 15. 15 times 5 gives 75 plus 1 times 5 is 5. We add 250 plus 75 plus 5, we are going to obtain 330. Next, if we take the number 20 in base 5, we convert this number to base 10. This will give us 2 times 5 raised to the power 1, which is simply this as 2 times 5. 2 times 5 gives us 10. Next, now we have to divide the number 330 divided by 10. This will simply give us, we saw the various techniques to divide any number by power of 10. We are going to write down the number 330.0. We are dividing by power of 10, which has only one zero. So we are going to take the decimal point one place to the left hand side. The decimal point now will be here. So this will simply give us 33. Next, now we have to convert 33 to base 5. Since we are working in base 5, convert 33 to base 5. We are going to do this convention by making use of repeated division. First column, we have 5. The base is 5. Then for the second column, we have 33. For the third one, we have the remainder. We divide 33 by 5. It gives us 6 remainder 3. Next, we bring down 5. 6 divided by 5 gives us 1 remainder 1. We bring down 5. 1 is less than 5, so if we divide 1 by 5, the whole number part will simply be 0, and the remainder will be 1. So we copy from bottom to top. The number 33 will simply be equal to 113 in base 5. So we conclude, therefore, we divide these two numbers 2310 in base 5 divided by 20 in base 5. The result will simply be equal to 113 in base 5. Underline the answer. Take now exercises for application. Exercises for application. Question 1. Question goes, evaluate the following. With the following. For A, we have 1 0 0 1 1 1 0 in base 2 plus 1 1 1 1 in base 2. B, we have 2 3 4 1 in base 6 plus 5 3 4 2 in base 6. For C, we have 7 5 2 3 0 in base 8 minus 6 5 4 6 in base 8. For D, we have 4 3 8 8 7 6 base 9 minus 8 8 7 6 1 in base 9. We go now to E. For E, we have 3 3 4 2 in base 5 times 1 3 2 in base 5. F, we have 1 0 0 1 1 1 in base 2 times 1 1, 0, 1 in base 2. For G, we have 1, 1, 0, 0, 1, 0, 1, 0 in base 2 divided by 1, 0 in base 2. For H, we have 1, 3, 3, 2 in base 6 divided by 4 in base 6. You will do well to answer this exercise for application. In the next video, we are going to do the correction of the exercises.